Welcome to the GMAT Strategy Podcast. You're here because you believe there's a better way to study for the GMAT, and so do we. We created the GMAT strategy to maximize your results and minimize your effort so you can get to the fun parts about business school and life as quickly as possible. My name is Isaac Puglia, and I've been teaching GMAT classes and tutoring privately for the GMAT for almost a decade, and I've achieved a 99th percentile score on the GMAT and helped thousands of students get into the business schools of their choice. I'm excited to be a part of your MBA journey since we all at TGS think our world can benefit from the best possible business leaders that we can find. If this show is bringing you value, please share it with your friends and family who are studying so that together we can make this process as easy and as painless as it can possibly be. Let's go. Welcome to Lesson 6 of GMAT Math Basics. If you don't want or need help with GMAT Math Basics, we've got tons of other advanced content in this content feed. Just search a few weeks ago and you'll start to find more advanced topics like how to be more disciplined, how to build speed, and how to build your other skills that go beyond just the math fundamentals that we're going to discuss here. The purpose of this segment of pieces of content is to help you be better with the core foundational material that's behind a lot of the math that you see on the GMAT. Today, we're going to be talking about how to do long addition. And if you've been following along, we've been touching on a variety of topics, each lesson that all have a common theme. Today, we're just going to answer one question, which is, how do you perform long addition? Now that you understand what operations are, like addition, subtraction, division, and the basic definitions behind them, it's time to talk about long operations, long addition, long subtraction, long multiplication, and long division, so that you can deal with larger numbers more easily, and so that you can understand decimals better, which is a topic that we are going to return to that I introduced you to recently. So let's go. So the first question here, and really the main question we want to address, is how do we add really big numbers without a calculator? Take a minute and think, do you really remember how to do long addition? Let me ask you this. What's 5 plus 3? You probably don't need to think too hard about that operation. If you do, our discussion today is really going to help, though. So if you're starting from the basics of just adding single-digit integers, then it's a great thing that you're here. But for a lot of you, 5 plus 3 is going to be relatively straightforward, and you might not even have to think about it very much at all. But what about what's 5,764 plus 2,789? It's a little bit of a different situation. If we take it up another notch, what is 576,398 plus 278,941? And what if you have to execute that under time pressure? And what if you have to execute that under time pressure in a situation where just one mistake in the entire sequence of operations could cost you the entire problem? It's a potentially difficult situation. And so I want to make that easier for you. That's going to be our big goal today, is adding these large numbers without a calculator and without computer assistance easier. So a very small percentage of people can do those types of computations I was just talking about in their head consistently without error. And that's fantastic for that very, very, very small percentage of GMAT test takers. I would say it's 0.001% or fewer. So by definition, the other 99.99% of us, myself very much included, this is going to be the reason that long operations are so valuable on the GMAT. So first things first, when you want to add large numbers that are either too big or just too complicated to do in your head, you want to stack the numbers on top of each other. That's step one of long addition. So what do I mean by stacking? You write one number, and then you write the other number directly either above it or below it. It actually doesn't matter the order that you stack the numbers. You'll generally get the best results by stacking each place value. You might recall our conversation about place value from a few weeks ago. If you don't know what I mean when I say place value, you're going to want to go back to the beginning of this GMAT Math Basics series and listen to lesson 1. So what I mean by stacking each place value is you make sure the units digit of the first number is right below the units digit of the second number. So I'm just going to assume that when you write the first number, you're going to write the second number above it for the purposes of this segment, all right? So you write the first number down, and then you write the second number down so that the units digits of those two numbers are right on top of each other. It would be like if you're typing on a computer, you would have to hit enter or the return key to get to the line below it or to the cell below it to get those things to line up vertically. Then you do the same thing with all the other digits. So you want to make sure you're writing it in a way that the tens digit of the first number is right below the tens digit of the second number, and that the hundreds digit of the first number is right below the hundreds digit of the second number. You want to stack the numbers so that the place values line up vertically. Let's pick a simple example and walk through this concept. Let's start with 107 plus 52. Now, for many of you, you might be able to do that in your head, but I just want to use it as an example of the technique, and then we will scale into more complicated examples in a moment. So again, the first step is to stack them. Write 107, and then directly below that, you write 52. But you want to make sure that the 2 from 52 is directly below the 7 from 107. So that should be like a vertical line, 7 on top, 2 on the bottom. Then you also want to make sure that you're writing it in such a way that the 5 from 52 is directly below the 0 from 107. That's what we mean by stacking. So you can think about it as lining up place values, or you can think about it as the units digit on top of the units digit and the tens digit on top of the tens digit. Whatever the easiest way for you to visualize and think about that is, just use that way. That's what I mean when I say you stack the numbers. Now, at this point, when you have both numbers stacked, I would recommend drawing a line below both the numbers. And I don't mean drawing a line below the top number and then another line below the bottom number. I mean drawing one line that is beneath both numbers. It'll help you separate the things you're adding up from the result of the addition, which we call the sum. You'll be able to see that a little bit more clearly. And it's a common convention when you are web searching things online or maybe watching video explanations of what I'm talking about. And it'll just help you track what your instructor is doing a little bit better visually. And I think it makes people less error prone. But at the end of the day, it's actually not essential. It's just recommended. So once you've stacked your numbers and then ideally drawn a single line beneath your stack, beneath both numbers, you'll start adding each digit from right to left. So in long addition, you always begin by adding up the units digits of the numbers. So if you don't remember what the units digit is, it's the digit to the far right of any number, but still to the left of the decimal point. So we're not going into decimals or fractions here. We're just talking about integers for the moment. We'll get into how to use long addition with decimals later. For now, we're just going to talk about integers. And it's the digit to the far right of the number, but still to the left of the decimal point. So in the number 1,719, 9 is in the units digit place, all the way to the right. It's also sometimes called the ones digit. So let's return to our example of 107 stacked on top of 52. And the first move in long addition is to sum the units digit, or add up the units digits. So we have 7 and 2 lined up vertically with a line right below the stack. We add those up and we get 9. And I recommend, when you're doing this by hand, writing the 9 at the bottom of that units digit stack, below the line that you may have drawn. So hopefully you can visualize that right now. We've got 107 at the top. We've got 5 and 2, 5 stacked below the 0, 2 stacked below the 7. And then we've just added 2 and 7 to get 9, and we write the 9 right below the 2 from 52. So we'll have a stack on the far right that's 7 on top, 2 right below that, and then ideally a line, and then right below that line, 9. That's going to be the units digit of the result of the addition, what I am moving forward going to call the units digit of the sum of 107 and 52. There's a couple things that can happen here when you sum the units digit. You can either get a single digit result like we just did, 9 is just one digit, or you can get a two-digit result. And we'll talk about what to do with the two-digit result in a moment. Let's stick with single-digit results for the moment. What we're going to do after we add the units digits to the two numbers is we're just going to repeat that process for all the other place values. So if we're adding 107 plus 52, we first sum the units digits. That's 7 plus 2 equals 9. Then we move to the left and we add the tens digits. So the tens digit of 107 is 0, and the tens digit of 52 is 5. 0 plus 5 is equal to 5. And so below our line, we will write 5 in the tens place of the sum. So you'll have a stack in the tens place of 0 on top from 107, 5 right below that from 52, and then below the line, you'll have 5, which is the sum of 0 and 5. So below the line now, we have 59. That's the tens and the units digit of the sum, respectively. Now you'll notice if you visualize 107 stacked on top of 52, that the 1 is kind of just floating above nothing. So you have a couple options for dealing with that. You can just bring any other digits that are not stacked down below the line without changing them. So here we could just like teleport the 1 down to the bottom of the line into the hundreds digit because 52 doesn't have a hundreds digit. And so the result would be 159 at that point. So that's option 1. Option 2 is anything that doesn't have a digit to line up with, you can just write a 0 in that place value. Let me use the example of 107 plus 52. So instead of writing 107 over 52, I'll write 107 over 052. And I'll line up the 2 with the 7 in the ones place, the 0 with the 5 in the tens place, and the 1 and the 0 in the hundreds place. As you get more comfortable doing this, you can either continue to put those zeros in front of numbers like 52 so that it makes it harder to forget what you're supposed to do in the process, or you can stop doing it and just teleport the numbers down like I was just telling you. I've personally found it conceptually helpful to write the 0 in front of the number, and the reason we're allowed to do that is the number 052 has exactly the same value as 52. In fact, I can add as many zeros as I want in front of a number without changing the value, because if you think about it, I'm just adding nothing to the number. It's very different than adding zeros after a number. We'll get to that in future lessons. But this is just another kind of trick of the trade to make the technique easier on you if you're starting from a very, very basic level and you want some structure around your long addition, or you find yourself making a lot of mistakes when you're doing long addition. So you can take this to the extreme. The number 0.000052 has exactly the same value as 52. And that's true when everything we're talking about is to the left of the decimal place. To the right of the decimal place, that changes. And obviously, or maybe not obviously, but just in case it's not obvious, if I start adding zeros to the right of 52, I'm getting much larger numbers. 520 is a much larger number than 52. 5200 is a much larger number than 52. To put this maybe in a more real context, imagine if you made 10 times the amount of money this year versus what you were expecting to make. That's probably a major difference in your income if you're like most people. But if you just add zeros in front of the number, it doesn't change the value. It just changes the way it looks, and sometimes that can make it easier to operate on. It's kind of a similar concept to what we did with common denominators when we're adding and subtracting fractions. We're not changing the value, we're just making it easier on the eyes. So just to recap, if you wrote 107 over 052, you sum the units digit, 7 plus 2 equals 9. You sum the tens digit, 0 plus 5 equals 5. And then you sum the hundreds digit, 1 from 107, 0 from 052, and you get 1 on the bottom, and your ultimate result is 159. That's the sum of 107 plus 52, or 107 plus 52. So again, many of you might be able to do 107 plus 52 without long addition, and that's not the point. The point is to prepare the basic approach of long addition so that when you are dealing with numbers that are too big to do in your head, you've got the basic skills ready. So let's move on to a couple more examples. How about 241 plus 136? First step, what do you do? See if you can remember. First step is you stack the digits. On top, I'm going to write 241. Right below that, I'm going to write 136. And I'm going to make sure that the units digit lines up, the tens digit lines up, and the hundreds digit lines up. So if you're driving or you're in the gym or something, just do this in the imagination. Or if you have the capacity to write it down, I recommend writing it down and following along visually. Then, what's the second step once you've stacked your numbers? See if you can remember. Optional, you can draw the line as your second step. And then the third step becomes add everything from right to left. If you don't want to draw the line, then the second step is just add everything from right to left. Add each place value from right to left. So you always start by adding the units digit first, and then you move to the left to do the tens digit, and the left of that to do the hundreds digit, et cetera, et cetera. It's the opposite direction of how you would read if you're reading like a book or a paragraph in English, where we usually read from left to right. So 241 plus 136, you'll notice the units digit on top is 1. Right below that, you should be visualizing or have written a 6, and the sum of 1 and 6 is 7. So you write that as the units digit of the sum at the bottom of the column that has all the units digits in it. Then we go to the tens place, 241 plus 136, we add 4 and 3. Those are the numbers in the tens digit. 4 plus 3 is 7. We write that in the tens digit of the sum. So on the very left of the sum, we have 7. And then right to the left of that, we have 7 again. Then we sum the hundreds digits, which is the 2 from 241 and the 1 from 136. 2 plus 1 is 3. And then now you've got your sum at the bottom of the stack, which should be 337. That's what happens when you get only single-digit results from adding each place value. But that's very important. That's the most basic kind of long addition, is you just add all the digits, you get single-digit results, and you write the sum of each digit operation underneath that respective column. Now, in both examples we've done so far, we've only gotten one digit as we've added each of the individual place values, and that was intentional. Now we're going to build up to a slightly more complicated situation. What if I add the 2 units digits as my first move and I get a 2-digit number? Let's take an example. Let's say 245 plus 137. Note that here, if I stack 245 on top of 137 and then I sum the units digit, I will get 5 plus 7 equals 12. But 12 is not a digit. I am not allowed to just write 1, 2 inside of a single place value in the units digit of the sum. So I don't do that. Instead, what we do is we just take the units digit of that number, the units digit of 12, 2, and we put that at the bottom of the units digit column. Then what we do is we take the tens digit from that sum, the 1 from 12, and we write that at the very top of the column to the left. So let me help you visualize this. We've got 245 on top, then we've got 137 right below that before we do any operations. Then we put our line at the bottom. We start by adding 5 and 7, the 5 from 245 and the 7 from 137, and we get 12. We take the units digit of 12 and we write that at the bottom of the units digit column. So we've got 5 on top from 245, 7 right below that from 137, and then right below that we'll have 2 from the result of adding 5 and 7 and getting 12. Then we take the tens place from 12, the 1, and we put it at the very top of the tens column. So it actually goes above the 4 from 245 at the top. That's called carrying the 1. You might remember that from your long addition instruction from the past, or if you've never learned long addition, that's a common way of expressing that move, where we take the tens digit from the result of adding the units digit, and we stack that in the tens digit column at the very top. And then you just do what we've been doing, which is you add all the numbers in that tens digit stack. So with 245 plus 137, instead of just adding 4 and 3 to get 7 now, we actually add the 1 at the very top from carrying the 1 from 12. We add that to 4 to get 5, and then we add 3 to that to get 8. And then we write that 8 at the bottom of the column of tens digits. So at the very bottom of this sum right now, I've got 2 in the units digit, and I've got 8 in the tens digit. Note that if we had gotten a 2-digit number again from adding up the numbers in the tens digit column, we would have just done the same thing. Let's say we got 28 instead of 8. We take the 8 from 28, we write that at the bottom of the tens column, then we take the 2 from 28 and we carry it to the top of the column right to the left of that, which is the hundreds column. So then we'd have a 2 on top of the hundreds column, and then we'd have a 2 from 245, and then we'd have a 1 right below that from 137. If we didn't get that, it's just a single digit result with 8, so we just pop that below the tens column when it's 245 plus 137. But it's the same idea if you do get 2-digit numbers when you're summing these. And we'll do another example of this in a moment. But that's all that you have to do in general to be great at long addition. You stack the numbers, lining up the place values. Optional, you write a line beneath that. And then you just start adding each place value. Add the units digits, write the units digit of that at the bottom of the units digit column. Then add the tens digits, write the result of that at the bottom of the tens column. Add the hundreds digits, write the result of that at the bottom of the hundreds digit column. And you just repeat that. And if you get a 2-digit number, you just take the units digit of that 2-digit number, write it below the column, and then take the tens digit from that result and write it at the top of the column to the left. That's it. That's long addition. So let's try a couple more examples to close this out. Try on your own, either in your head if you're on the move or on paper if you have that ability. What's 555 plus 444? First, you stack the numbers, 555 on top, 444 right below that. Start by adding the units digit, which is 5 plus 4. That's 9. So we write 9 below the 5 and the 4 in the units digit column. Then we move to the tens digit, which is 5 plus 4 again. Same thing, write a 9 at the bottom of the tens digit column. Then we go to the hundreds digit, 5 plus 4. That's 9. We write that at the bottom of the hundreds digit column, and we've got the sum of 555 plus 444, which is 999. So when everything adds to a single digit, it's a very simple process. You just add the column digits and write the sum at the bottom of each column. That's it. Let's try an example where we get some double-digit results. Let's add 1,234 to 5,678. And if you're listening to this, that's just 1, 2, 3, 4 is the first number, and 5, 6, 7, 8 is the second number to make that a little easier to keep track of. So, what's your first step? You stack. 1, 2, 3, 4 on top, 5, 6, 7, 8 right below that. 4 and 8 are lined up in the units digit, 3 and 7 are lined up in the tens digit, 2 and 6 are lined up in the hundreds digit, 1 and 5 are lined up in the thousands digit. We start on the very right by adding the units digits together. 4 plus 8 is 12. We take the units digit of 12 and we write that at the bottom of the units digit column. So 2 is going to be the units digit of the sum of 1, 2, 3, 4 plus 5, 6, 7, 8. We start with 4 plus 8 on the far right. We get 2 on the bottom, and then we carry the 1 to the top of the tens column, and we have 1 on top, 3 right below that, and 7 right below that. So we add 1 plus 3 plus 7, and we get 11. Again, that's a 2-digit result. So you take the units digit of that result, and you write it at the bottom of the tens column. So below your line in the sum, you should have 2 for the units, and then to the left of that, 1 for the tens. Then we take the 1 from 11, that's in the tens place, and we carry that to the top of the hundreds column. And in the hundreds column of 1, 2, 3, 4 plus 5, 6, 7, 8, we now have a 1 at the very top, a 2 right below that, and a 6 right below that. So we just sum those numbers. We do 1 plus 2 plus 6. That gives us 9. There's only one digit in that result, so we just write 9 at the bottom of the hundreds column. Then you add the thousands digit, which in this case is just 1 plus 5. That's 6. So we write 6 at the bottom of the thousands column, and we have our final result, which is 6912, 6,912. Now you know how to do long addition. It's super useful because some questions on the GMAT require you to just add a bunch of big numbers without a calculator. And you can add more than 2 numbers at a time. But I strongly recommend, just for clarity's sake and cutting down on the number of questions you know how to do but miss, only adding 2 at a time, using the system I just gave you. And then if you need to add a third number, just stack that third number below the sum and do the long addition again. And then if you have to add a fourth number, stack that fourth number below the sum. And that's why I personally like to write the first number on top, then the second number on the bottom, then do the sum, then the third number below that, because to me, visually, that's a very familiar way of doing math, just moving from the top of the page to the bottom of the page if I have to sum a lot of very large numbers. Now, it's also worth noting that many GMAT questions explore the concept behind long addition, not just asking you to add a bunch of big numbers. For example, some questions might ask only about the last digit of a sum, which is kind of like an interesting thing, which is another great example of this theme I've hopefully been bringing up a lot in our time together in this GMAT Math Basics course, which is that the GMAT likes to test these simple concepts in very complicated and intense ways. And so understanding how the mechanics behind the methods work can be really, really valuable for helping you to execute them on those like higher levels or more complex levels, even though the concepts themselves are quite simple. So hopefully I've really given you a leg up there. Now, quick note, in the data insights section, you have access to a calculator. So if you're taking the exam soon and you're not going to make it to the end of this particular program of GMAT Math Basics, then I don't recommend using these systems in the data insights section. But they're going to be super important in the quantitative section where you do not have access to a calculator on the GMAT, just in case you weren't aware of that. It's very helpful to know. So next time, we're going to pick this subject up and we're going to talk about long subtraction. Interesting anecdote. When I started studying for the GMAT in my 20s, I actually came across a bunch of GMAT questions that required long subtraction, and I realized that I had never learned it. So that was a very wonderful and humbling experience as an adult, going back to some basic math and relearning long subtraction. So hopefully I'm going to give all of you a very, very big competitive advantage over my past self. But even if you've learned log subtraction and you've been familiar with it in the past, if you're not currently familiar with it, I think you'll really enjoy next week's episode. So it's very related to a lot of the systems we talked about today for long addition, but it's also got some really important differences. No pun intended. Until then, as always, my greatest hope is that this material will make your studies as easy and as painless as they can possibly be. If you want more tips and strategies for optimizing your performance on the GMAT, please head to our website, thegmatstrategy.com, which is hyperlinked in the description of this content. So you should be able to click on the description of this and click that link and get to our site. If it is our link stacker of the day, then you'll want to click on the very top link. We'll take you to our website and check out our free video on how to achieve your dream GMAT score in half the normal time. In the meantime, this is a weekly show, so please subscribe. And as always, please stay positive and please stay consistent with your studies. I'll talk to you all soon.